Hi folks, welcome back to Physics with Captain Rod. I'm making this one to help you Physics 109 students out with numbers 12, 13, 14, and 15 in your Unit 1 homework. All right, so let's chat about number 12. So this is a really rough sketch here, but you should be looking at a graph that looks basically like this. Now the graph that you're looking at should have a lot more detail. It should have numbers on this axis and numbers on this axis. But I'm just going to use this for chatting about how to do this problem. All right, so time A on the graph is like roughly here. So they're talking about basically this point on the graph. So when it says estimate the rise and the run, what they're talking about is the slope. So the rise, if I pick a couple of points like here and here, the rise is this distance, and then the run is this distance. That's what they're referring to. Okay, part B, let's see. Part B is roughly here on the graph. So, it's here on the time axis. So we're talking about like here on the graph. So pick a couple of points here, like maybe, I'll do this one in green, like maybe this point and this point. And you should notice something fairly significant about the rise. I don't want to give it away. It's up for you to come to that conclusion. But, it's... rise are vertical changes and runs are horizontal changes. And part C, estimate the rise and run. Let's see, part C on the graph is like here. So they're talking about like this point on the graph. Okay, I'll do this one in blue. So use like this endpoint and this endpoint here, and then this is the rise. Figure out what that is. And again, you're getting these values over here on the axis. And then this is the run. And you're going to get these values like here and here on this axis. And the last question says compute the velocity at part C. So velocity, when it comes to a position graph, is equal to slope, which is rise over run. So take the rise you have, which was this distance, divide by the run, which is this distance, and that will give you the velocity in meter per second. All right, so that's probably enough with 12. Let's chat about 13. Let me clear this up here. Let's see, a high-performance sports car can go from 0 to 100 miles per hour, which is 44.7 meter per second in 4.6 seconds. Now again, you folks may have different numbers on your homework, but I'm going to go ahead and write down the numbers I have on the one I printed out. So the 44.7 meter per second in 4.6 seconds. And let's see, what is the acceleration of the car? So acceleration, right, is the rate that your velocity changes. So formula-wise, it's equal to change in velocity over change in time. So basically, you're going to use this as your change in velocity, this as your change in time. And you're going to get a number that's going to work out to meter per second, which can be written meter over second squared if you want. Part B is very, very similar, except in part B it says the same car can complete a stop from 31 meter per second in 3.1 seconds. Now in part B, the velocity is decreasing. So your change in velocity, when you calculate change in velocity over change in time, is going to be minus 31 meter per second because the car's velocity is dropping. It's getting smaller and smaller and smaller. So that should get you through, let's see, 13. Okay, I think I was going to do, I kind of erased it here, but I think I was going to do 14 and 15 next. So 14 is asking about acceleration, so I would start by writing out acceleration is equal to change in velocity over change in time, or delta v over delta t. Okay, it goes from 0 to 40 meter per second. Whoops. In 0.16 seconds. Now, again, you may have different numbers here. I'm just using the numbers on the printout I have, but the program is designed to give everybody a random distribution of numbers. All right, so your change in velocity, you're going to get from these two numbers. It went from 0 meter per second to 40 meter per second. And then the change in time is this number. And I'm just going to go ahead and chat about 15. 15 is virtually the same. A rocket accelerates from rest at 40 meter per second squared, or 40 meter per second per second. What is the speed after 41 seconds? So write out this formula. Acceleration is change in velocity over change in time. Now here, the acceleration is a given number, and the delta t is a given number. And then put those numbers in, rewrite the formula so it looks like a number, and include the units in meter over second squared equals change in velocity over some other number, right, in seconds. And then you're solving for the change in velocity for part A. For part B, where it says how long does it take the rocket to reach 6,700 meter per second, and again, your homework may be a different number. For part B, write this formula out again. Acceleration is equal to change in velocity over change in time. Use the same acceleration that was given earlier in the problem. And then when it says to reach a final speed of 6,700 meter per second, use that or whatever number you have for your change in velocity. And that should hopefully get you through 15. So I'm just going to go ahead and end this video here. I hope that it helps. Have a great day.